Here's another example. This one is precipitation. What's precipitation? Two ions getting together to form a solid. So it's just the opposite of the dissolution process, right? So if you're talking about precipitation of calcium carbonate, that would be from calcium chloride and sodium carbonate. That would be calcium from the calcium carbonate and carbonate from the sodium carbonate. That would be your net ionic equation, right? Calcium from the calcium chloride, carbonate from the sodium carbonate gives you calcium carbonate. This is just the opposite of the dissolution, which is calcium carbonate gives you calcium ions plus carbonate ions, right? The KEQ for this is 1 over the KSP, right? The KEQ for this is the KSP of sodium carbonate. Let's work this problem out using traditional way it's done in textbooks. So let's just do it this way. Let's use this one right here. You're given equal volumes of 10 to the negative 5th molar calcium chloride and 10 to the negative 5th molar of sodium carbonate. So what would be our initial concentration for calcium carbonate? Well, this is excess, right? Solid. Actually, there's none, right? There's no calcium carbonate because you're mixing two solutions. What's the initial concentration of calcium? Is it 10 to the negative 5th? You're mixing equal volumes. So your volume has doubled. So it's no longer 1 times 10 to the negative 5th. What is it now? It got diluted twofold, right? So your initial concentration of calcium is only 0.50 times 10 to the negative 5th. Okay. So initial concentrations, 0 for you don't have any calcium carbonate. This is 0.50 times 10 to the negative 5th. Your carbonate is also half of this original amount concentration because, like I said, you've doubled the volume when you mix them. So this is 0.50 times 10 to the negative 5th. This question is asking whether precipitation will occur. What does it mean if precipitation occurs? That means which way does the reaction go? The question is really asking, will the reaction go to the left, right? Going to the left is precipitation. And when will precipitation occur? You remember? When will the reverse reaction occur? When you comparing Q and KEQ. When Q is greater than KEQ, right? It goes to the left. Remember from your earlier lesson. So all we have to do is calculate Q in this case. What's our Q? Q is calcium ions times carbonate ions. What's our calcium ions concentration? 0.50 times 10 to the negative 5th. And your carbonate is 0.50 times 10 to the negative 5th. And that gives us 0.5 times 10 to the negative 5th. Okay, square it, right? It's 2.5 times 10 to the negative 11. Compare that to KSP, which is our KEQ. What's KSP here? 5.0 times 10 to the negative 9. So, A, yes. B, no. Will precipitation occur given that Q is 2.5 times 10 to the negative 11 and KSP is 5 times 10 to the negative 9? No. Okay, why not? Q is less than KSP. So, will the reaction go forward? No, there is no solid calcium carbonate, right? It can't go forward as written because you don't have any calcium carbonate, but it will not go in reverse either. Okay? By the way, Q in this case, when we're dealing with KSP, Q is also known as the ion product. Okay? So you might encounter that term. So when we're dealing with KSP and solubility equilibria, ion product refers to the reaction quotient that you can compare with KSP.